It's my pleasure now to introduce our first keynote speaker for today. It's Tobias Hodel. After finishing his PhD at the University of Zurich in 2016, Tobias worked as researcher in the project READ, which stands for Recognition and Enrichment of Archival Documents, which was at the Staatsarchiv of the Canton of Zurich. He also was a project manager of the Königsfelden Digital Edition. Since 2019, he is assistant professor for digital humanities at the University of Bern. His research focuses on the digital humanities, digital history, and machine learning in the humanities, which we'll get now into a bit in this talk, Big Data, Big Responsibility, Why Machine Learning Needs New Forms of Cooperation.
Thanks again. Thanks a lot, Marian. Thanks again for the possibility to talk here. And again, very much thank you, Marian, because he's one of the responsible people that we're really here. So he has done like all the small steps that need to be taken to be here. So thank you. Good. What I would like to do is basically some sort of a thought experiment with you. So what I don't have for you is basically the perfect keynote that tells you how we should deal with big data, but rather this is a challenge. And I think we're currently in the situation that we need to think together how we should deal with that. So questions like, how do we cooperate in this world? And I will try to make the argument why it's so important that we cooperate. How are we fair? And of course, you will see the notion to the fair, to being fair and adhering to fair principles. How do we care? This is, of course, the idea for the care principles that I will go into detail a bit more. And also, why does this really matter? So the question's not, so we don't deal with facts for the moment, but rather with just challenges, with questions, and how we can remain in the end as critical scholars that we should be, and not basically throw everything overboard that we learned for the past 200 years, but rather how can we combine research cultures from the sciences, but also from our scholarly tradition. And I understand myself very much as a scholar from the humanities, although I try to implement methods that don't come from these fields originally. So what I will do is also based on my personal background. Marian already mentioned that in 2016, I had the chance to join READ. At that time, nobody knew what that should be. There was basically just a large research project funded by the European Union. We got at that time 8 million euros with the basic idea that we should do something about text recognition for handwriting. So the claim or the vision of the project, and also the promise, because you have to promise something if you apply for money, especially if you apply for some millions, was that we can revolutionize access to these handwritten documents. At 2016, the results were not very staggering. I will talk about that in a second. Right before we started READ, there was this FAIR publication that we also need to talk about by Wilkinson and I think 49 other co-authors that laid out basically ways how we should cooperate in this age of data. 2019, the situation was already a bit different. So you see, READ became the READ Cooperative. So it became somehow institutionalized, also became something like a business model. And in 2020, I'm relying mostly on Hugging Face. I don't know how many of you do know Hugging Face? Only one, okay. So that's good to know, because then I know that I will need to give you some background. So if you're dealing with natural language processing applications, Hugging Face is basically your hub. It's also a company, but it's basically something like a collection of language models, but we will come back to that. So back to 2016. In 2016, we had this READ consortium, all the partners that basically got money from the European Union. And if you go through the list, you see something like a division. Now the division should come up. Here is the division. So something, so like in soccer, the ones that above and the ones below this, this little line. So on the upper side, what you can see basically are the technical partners. So the ones that have been developing the text recognition, for example, in Valencia, who were at that time leading with hidden Markov models. So they were the ones that basically won all the contests for text recognition. But there were also the Rostock guys who came up with new ideas with neural networks that could do the trick even a bit better. We had partners from Leipzig who were providing us with large dictionaries. And then you had, like, below the line, you had something like demonstrators. So people, especially archives and institutions, that wanted to profit from the new technology. So you basically had the ones that were the providers, and you had the consumers. And I mean, I still really like very much this division, but still in 2022, I think this wouldn't be so clear-cut differentiated, but rather it would be much more of a mixture. But at that time, it was clear. So the archives were the ones providing the material. Zurich, like 200,000 pages of already transcribed material. I usually point then to Margit, because she was one of the she was at the forefront of making that project possible in Zurich, and then also basically was in the background responsible that READ could be joined, but also Passau, for example, where 100,000 and more of so-called records for marriages and deaths were recorded and then made legible thanks to the technology developed within READ. So, but what I want to say is basically we have this producers, consumers, and I think it is going to shift, and this is one of the goals of this talk. Right at the same time also, so basically around 2015 to 2020, we see the breakthrough of deep learning. So when we started, you can see that in a lot of fields. I will concentrate here on the two fields I'm currently working on. The one field is in text recognition. So when we started, we had, with this hidden Markov models, we had 20% character error rate. That's basically gibberish text. It sounds good because you think, okay, only every fifth character is wrong. But if you're looking at text, you will realize that it's not really text. It's some assemblage of letters and characters, basically. Then from 2016 to 2018, we could, thanks to switching to deep learning, we could push that down to an error rate of 3 to 5%. So now we're somewhere where you have something like legible text. If you're a philologer, you probably are not really happy with that either, because it's still it's 3 to 5 errors per 100 characters. So if you recall that an SMS used to be 256 characters, this is still in the vicinity of 10 errors within your SMS. So that's basically that you're wrong. But still, it's legible in a sense. The same time, and this is basically the same technology, but applied a bit differently. We see language models from this word-to-vec, very static, I call it usually half-baked representation of text, to elaborate understanding of text, thanks to the switch from word-to-vec to word. That was basically the switch from telling, okay, each word has one representation, to word, where you have a bidirectional analysis. So a sentence gets analyzed from two sides. So basically, reading the sentence from the start to the end, and from the end to the start. So basically, embedding also something like context. We'll come back to that. So what you can see is data somehow seems to become key. Now, when you think about what a neural network does, you will realize that it's not maybe becoming key, but it's definitely, data is becoming the most important asset to deal with. So I won't go into into details here, but basically how very simple neural networks worked for text recognition, and that's a representation from graphs in Schmidhuber, and I like to show that because it has been developed at USI. Schmidhuber was basically the inventor of the LSTM. That's a very basic cell structure. So what they were doing already in 28 and 29 was basically assuming that you don't have to tell the computer exactly what to look for, but rather have a computer teach itself what it does. So that's basically the idea of a neural network. So we have these different weights, and now it's a bit better that I can't point you really, but let's try it here. So we have to read this thing from the bottom to the top. So you start here with some basically reading the image. So here we're processing the image, and then we are switching here to this LSTM. So basically these cells, they are all interconnected. And what we can see basically is that we don't see anything anymore. So until here we can understand what's happening. So you're reading basically with a sliding window, you're going through the image, but here the cells do anything. So what happens basically is here up here, we tell the machine, this is the result. And this is basically the input. So please optimize this input to this result. So go through this image several times and try to come up with this solution. Now, what we have to understand is that the input and the output, for humans, they are basically similar, but epistemologically, they are completely independent. So this image does not have anything to do with this string. So here we have some Unicode-based string, and here we have some pixels. And we basically make the machine think that there is a connection. And of course, as humans, we see there is a connection because there are Arabic characters, and there are the same, ideally, characters. But still, here, pixels, strings. They have nothing in common generally. And that's basically what we're doing with machine learning all the time. Also, what I would like to do is here is the notion of artificial intelligence, or the term artificial intelligence is, in my humble opinion, highly problematic. So I usually try to avoid it as far as possible, except if I apply somewhere, because then you show off and say, okay, we're doing artificial intelligence, of course. But in general, I don't believe in artificial intelligence with the technology that is available to us at the moment. This is basically, and we will come back to that in a second, because it's the discussion is brewing for the moment again. So basically what we are doing is we are showing machines huge amounts of data, and the machine tries to imitate it or tries to cluster it, depending on whether we're using supervised or unsupervised machine learning. We won't go into the detail here in this talk. But basically, so takeaway message is epistemologically completely independent, and the machine works with this backpropagation. So the machine tries to teach itself or tries to alter its weight. So these cells get altered all for each epoch a little bit, and the output is going to improve, and it's going to be improved the more data we are having. Also at the same time, and it's not an incidence, but rather it's like this push for more, let's call it data science, very generally, is that we had access, like every one of us got access to very basic coding infrastructures. And I think that's also a game changer, because if you have to set up on your computer in an environment where you then can start coding and then you will get some error, this is just like the hurdles get too high. So what happens is with the Jupyter notebooks, with Google Colab, what we got is basically an infrastructure that we could instantly use. So you go to a web page, you basically can use a Raspberry Pi. So the simplest of all computers, if it has an internet access, you can go to Google Colab, and you will have access to enough computing power to basically do machine learning. So we not only have basically the tool, the deep learning tool, but also we have the infrastructure to really do something without the hustle of installing everything. So we don't only have the idea that we need to work with data, but also the means to use this data. Now, and that's a bit from what we have done last year. What we could demonstrate is for text recognition. And I think that's a good example. It's basically showing that if you have enough data, you can generalize models. So based on enormously much material from already transcribed material, we were able to produce text recognition models. That's now based for German current, written in the 19th century. And you get there somewhere in the vicinity of this 4% character error rate. So really good legible text for text that the system never has seen before. So the system doesn't know the scribe or the writer or the hand, but rather it just knows the style. So we can recognize German current right from the top without fine-tuning or without providing our own model. Everything based on just enough training material. At the same time, it was also possible to show that you can have something like too much data. This is why this last column here is part of this table. This is the largest ever trained text recognition model. It's based on this 150,000 pages that had been provided by the State Archives of Zurich. But the problem there is it's written by only a very narrow set of scribes. So in there are about all the 30 scribes that worked for the State of Zurich in the 19th century and made this minutes that we worked on. Because there were only this 30 people in it, the model became too narrow. So if we use this model on scribes it had never seen before, it didn't really provide good results. I mean, 10% CR is still, it's not bad, but it's really a difference if we create data sets that are really diverse. And that's basically also this first argument, that if we want to go into this deep learning, machine learning world, we need to provide really diverse data sets. Otherwise, we see this overfitting, and then it's going to be really specialized just on only a few, in this case, scribes, but also basically representations of the world, if we want to say so. This is basically a representation of the, let's call it the best model that we used for this test. And as you can see, it really needs quite a lot of data. So we're looking here at a model with about 6 million words. I don't recall the lines exactly. There's something in the vicinity of 900,000 of lines, so written lines. That's basically the entity we're dealing with, because it's more or less impossible to narrow it down to single words visually. Of course, you can count the words, but the lines are basically the entity that you're training on. So where does this? So this is basically the first call to really. This is why we need to cooperate if we really want to use deep learning. You cannot come up with 6 million words within one project. So you were talking about you have your 4 years. So and then you can deal with 22 or with 20 manuscripts with 20 books basically. So the 6 million words are basically out of reach for you. So this is basically one of the first arguments why it's so key to really cooperate together. And also talk about some standards. I will come back to that here. I mentioned only the most frequent providers of data. So besides the State Archives of Zurich, it's also University Archive in Greifswald, where they're really working intensively on that, and other projects in Berlin and in Zurich as well. So really only thanks to this huge amount of data it was possible to train this model. Now the call here, and I already mentioned that, is of course we need to do this fair. So what we need to do, and this is also what the Swiss National Science Foundation is make you do, is basically you need to provide your data, you need to think your data management, so it needs to be findable, accessible, interpretable, reusable. You all know this keyword, but I think that's only the first step, because preparing data fair is okay, but still this will be within your own world. And this is why I liked really the question from Julien earlier. So is it being provided by IIIF, for example? Because, and we won't go into detail about this I like to show parchment, so this is why I'm showing that. But also, I mean, it's the argument why we need to cooperate, but not only on like a bigger level. So it's not only about providing images based on a specific framework or a consortium, but rather we need also to cooperate on smaller things. Because if we want to achieve something like highly sophisticated, and I'm aware that abbreviations is not what everyone is interested in, but it's a good example to show how complicated it can get. This is why I took this example. It's basically what we can do now is, thanks to this deep learning, is not only recognize characters accurately, but we can also expand these abbreviations accurately. So basically, we can train a machine that not only identifies here, this is the Unicode representation of it. It's not exactly the same, but it's basically the same sign. It's like if you use an A, different shapes of an A. So both signal an et, and it's an Latin abbreviation of an et. So here you see, okay, it's identified as abbreviated, and you have here the expansion as the et. But still, if we want to do that, it's not enough if we have one project working on that, but rather we need a community to talk about abbreviation. And I know that's not the sexiest thing to do in the world, but still it gives us an insight how complex it's going to be to how to basically systematize our data in order to make it usable the way we're used to deal with it. So let's get to some interim conclusions. We, as scholars, I would say, we need to cooperate, and we are at the same time not only the consumer of our data, but also we are producer of our data. So we are basically part of a circle. So we prepare our data and we consume other data, and this is basically a circle that should help us also then use machine learning techniques. We need to work with standardization, but here, this is basically where we really need to narrow it down a bit. So on the one hand, we want to have it as standardized as possible, but not for the cost of simplifying too much. So basically, when do we start losing information that we deem crucial for certain research questions, for maybe some perspectives on the material? And so this process, this ongoing process, is really time consuming and also not the most amusing thing to do, because you will crash on some parts. We have seen this in the early zeros, in the early 2000s, when the literary scientists and historical scholars were clashing over digital editions. So they had complete different understanding of what text had to be edited. So they basically did editions completely independent of each other, and not so they couldn't comply on the same standards. And for some reasons that makes still sense. But that means standardization with regards to data models. Julia made the perfect pitch here. So how and why you could use CDOC CRM, or rather like subsets of it. So that's basically the direction it could go, but also data formats. So how can we then exchange the data? That would be like a call for scholar editions, for example, for this TI XML world, where you just know, okay, how this file could be looking like. The consequences there is publish your data, publish it as early as possible, because then, since it's available, it will be possible for other researchers to do stuff with it, and then basically make it available to you as well. And also, please make it reusable, which means that we have to start thinking about copyright issues and Creative Commons. But you're aware of that, so I won't go into detail in that. And the second point basically is we need to form these communities. I think the IIIF consortia is very well established. We have, but also like something like the Data for History consortium. There is the TI the text encoding initiative. That's also another consortium. And I think we need to be part of this consortia to also start thinking about, not start, but continue thinking about how should our data be modeled and how can we basically specialize without going too deep. And there is not going to be one fits all, but rather how can we structure several trajectories that you can go with your data. But now, is FAIR really enough? I'm a huge fan of Molani Hicks et al.'s Computer is on Fire, where they basically show that what we're doing in deep learning might work, or we might understand it as working, but it's really like highly problematic. We have the whole problematic of bias. Moritz mentioned it earlier. We have the injustice problems, and in the end, we can't really explain why it's working, why it's working and how it's working. We will see that also in a second. This is paired with the highly regarded algorithms of oppression by Sophia Noble, but also Rua Benjamin with her race after technology. There are, I think, in the science and technology studies, you will find quite a few others that are really interesting, but all point in the same direction. Deep learning is cool somehow, but we need to take action that it not start making these decisions for us, but rather how can we stay within the process and how can we make these systems more just and ethically suitable. Now, to make this argument, I need to switch a bit over. So let's very, very briefly go to language modeling. So because so the first example basically was the text recognition. Now we want to do something with this text. So we want to do something with language. So what we try to build is a representation of our language, and this is where the idea of this word to vec comes from. Already Firth it's not Colin Firth, in the 1957 said, you shall know a word by the company keeps, and it basically doesn't mean anything else that we have to look at context in a narrow sense. So basically what words are combined with what other words. So in this example, this is always the same example with the cat and the dog. You see that cat and dog are somehow related. They appear in the same sentence. Sometimes the word cat is used, and some other times the word dog is used. And with that, you can start calculating a so-called vector, and which you then can use to train. You can start training basically a neural network that then creates a vector for you that is representing basically how this word is occurring. Now, to make it a bit, hopefully a bit more understandable, this is a 3D representation of a vector that's way larger. So usually you start training vectors in the vicinity of 100 to 1000 dimensions. And then for a human, it's impossible to think in this dimension. So what we do is we scale it back with principal component analysis to 3 dimensions, where you then can see, okay, there is a word and it stands in relation to another word, and we can basically visualize that in the 3D grid as we try to do here. What we try to do here in the same time is we try to demonstrate that this representation needs to be context dependent. So what you have in word2vec is basically each word gets assigned one vector. So the cat is always this idea of a cat, and it doesn't matter in what context the cat is used. Maybe with the cat that could be working. If you're using another word that has some ambiguity, that doesn't work at all. So this is why, and this is where this whole bidirectional influx comes in. So what we did then, that's not me alone doing, but rather what people started doing is basically trying to create language models that that are influenced by the words that are before and after them in the same sentence. The example here is also, again, with pre-modern languages. So that's from the Königsfelden corpus, so basically from the scholarly edition we did. We also created language models. And what we did here is we took one word that's highly ambiguous, that's Stadt. So Stadt could mean the city, but it could also mean stehen, so standing. And what you can see is that these different points here, they represent always one form of this standing or the city. And interestingly, so this is how we also try to understand how this language model works, because the embeddings are getting trained without any influence from basically our knowledge system, but rather it's basically just looking at, okay, what words are occurring with what other words, and I create you a vector like this. So we basically have to inductively then come back and think about what does this really mean? So how does this signify a difference? And like in parentheses, this is also a problem that we calculated it in 3 dimensions, because if you scale down from 1000 dimensions to 3 dimensions, you will lose a lot of information. So this is basically also the idea to check if PCA is really fit to the job. And at the moment, I'm not really sure. But that's an ongoing discussion. So, but basically, or like the takeaway message here is we have the ability to model this and to represent this, but also we have the ability and the capability and maybe also the obligation to try to represent it in a visual form, then because we need to somehow interpret it, and you cannot interpret 1000 dimensional vector. I mean, you can try, but I don't know. So, okay. So what happens now? I already mentioned BERT. BERT is basically a transformer-based model. So that was the introduction of these transformers. It has only 340 million parameters. And it basically is in every search that you're using, you will find, if you're using Google, BERT is going to be used in the background, because you want not only to search for the specific string, so the single characters, but rather what you meant with that string. So what you do if you're using a Google search is basically you get the representation of the words you entered, and this will lead to searching similar terms, for example. That was 2016. Then 2018, there came this new project at that time that was OpenAI, and they said, okay, this 350 million parameters, that's nice, but what we want to do is we want to start generating text from text. So basically, we want to train a model that's not only capable of this embedding, of this vectorization of text, but rather we want to produce text. They used then 1.5 billion, that was a world record at the time, and what came out was somewhat English text. So basically what you can do is you can enter a prompt, so something like the beginning of a sentence, and the system will then create some text out of it. They tested it out, they open sourced it also, so you can, GPT-2 is completely open source, you can use it. 1 year later, 2018, they came with GPT-3. You can see we're going from 1.5 billion to 175 billions of parameters. And that was the moment when people said, okay, the college essay is dead. I don't know if you're familiar with the American system. If you're applying for a college or a university, you have to hand in an essay. You can choose from several topics, and they're shifting each year a bit. So basically what you want to achieve in your life, or if you're president for that, something like that, you get it. But now with GPT-3, what you basically can do is you can start with this title, and the system basically will create this essay for you. GPT-3 was the moment when people were not able to distinguish whether this text was made from human or from this computer system. It's really like, you can read it, it's semantically rather sound. Sometimes it breaks because the system basically loses his thought. But that happens with humans too in some text, I realized. But still, so, and what happens last year is, of course, OpenAI has some commercial interest also it's quite expensive to train GPT-3 models. We tried it for a project. They will charge you about $200 if you want to use the large model per 3 or 4 epochs. So it's really the commercial interest that's driving them. So what happens, Google comes, of course, and says, yeah, it's interesting with your 175 billion parameters. We are going with 540 billion, so 500 billion parameters. And of course, what happens then is this Palm infrastructure beats then the GPT-3 on a variety of tasks. And the tasks are quite simple, so you have to understand a question. So it's basically question answering systems, where then Palm was stronger. Now, this is, in a sense, this is really cool, and it's an immense opportunity, because you can basically take BERT and use that for your own task. This is what everyone is basically doing in natural language processing all the time. It's a bit harder with GPT-3s in this closed source, but also, so basically this is what's going to happen with Palm. But what you don't see is, or what you don't are made aware of right away, but start realizing pretty sure, what we're creating here is basically this information machines, or maybe also information machines, that you can use at scale. So basically to program a bot that is constantly tweeting out something that has some information value is currently or nowadays possible at no cost, and with probably no one recognizing for the first 30 days or so, because the text that is being created is really understandable and seems to come from a human. Also, what you don't see is, to train these models, we create enormous CO2 footprint. I will not go into this environmental, sorry. I will not go in this direction. That's for another talk, but just keep that in mind. Now, of course, if there is something cool, you want to try it out. This is what we're currently doing with GPT-3, with a text generator. And we are lucky that the National Library was also interested in this. And for the next exhibition, we are training basically a Walser text generator. So you can prompt Walser to tell you anything about anything. And that could be looking something like that. So the prompt is eine Digital Humanities Summer School nach der Corona-Pandemie. Unfortunately, Walser only talks in German because all we have from him is German text. So sorry about that. And I didn't want to spoil it by translating, because then I had basically 2 machine learning systems above each other that maybe, yeah, wouldn't lead to the same result. So, okay, we have a Digital Humanities Summer School after the Corona-Pandemie. Ja, es ist ein bisschen seltsam, fuhr sie fort. Nicht so wie der, den man als Denker bezeichnet, sondern eher als einen gewissen ganz... Okay, wasn't really happy with that one. So, of course, you redo it, and now it gets a bit spooky, because the system realizes that we're in Rome, for whatever reason. I probably can explain it in a second, so don't get spooked too much. So, eine Digital Summer School nach der Corona-Pandemie in Rom wurde vom 4. bis zum 5. November abgehalten. Okay, it's not so sure with the dates, but fair enough. Teilnehmer dieses Semesters sind zum Beispiel die Direktorin des Goethe-Instituts. We don't have anyone from the Goethe-Institute. Okay. Frau Tobler, and then that's really cool. Frau Tobler, she's present twice. Now let's redo it for the sake of it. And now it's basically, so it seems to be the end of the sentence. That's not very logical. But now there's this young man that's standing in front of this image of Lady Edith. Yeah, okay. And for the last example, now the summer school has moved to Florence. Wouldn't mind about that either. But this is basically where we start. So this is why I think it's key. So we have this GPT-2 model that we're using. So that has been fed with immense amounts of text data. And obviously the summer school appears within, and it's coupled with locations. And somehow it's coupled with Italian cities, seems to be. I mean, it can also come a bit from Walser. I'm not so sure about that, because I mean, the advantage that we're having now is basically we always can go back to the Walser corpus and we can see, okay, what words, so we can basically do collocation analysis. So we have the corpus and we can always go back and see, do some words appear quite frequently with others, and is maybe this why it's acting like that? Because the trained models we cannot really analyze. It's rather we only can analyze the output and then try to make sense out of it. So, so for example, the last part, Gefühle, that's very frequently occurring at Walser. So this sentiment that is reflecting, that's quite often. Good. Now this is basically playing around, but also trying to understand it. But now if we go back to serious business, what does this cost to do? So for Palm, I found this small article where someone really tried to do the calculations. So, and what he did, that's Leonard Heim. So what he did basically is, what would happen if you would go to Google, and it has been trained by Google, and they charge you what they usually would charge you to use their calculation power. So that's their TPU cluster. Basically, TPU is a tensor processing unit. That's something similar to CPU and GPU, but with more calculation power. So you would need to buy some of this teraflops. Flops is basically a number of calculations being done per second, and let's leave out the calculation. It comes up with one number, and it's over $23 million just to do the calculations for this one final model. So there is no engineering involved here. So no one has been paid. No one has prepared any data, or so. It's just calculating it on a cluster. So basically what's happening is we're using models that are several millions of dollars, cost several millions of dollars just to produce. The consequences, and it's of course it's coupled with all the hype. So at the moment is really with this Palm, we're in the vicinity of this so-called AGI, artificial general intelligence. That's basically when the machine is as smart as a human, or basically smarter, because at the moment the system is as smart as a human, it can improve itself, so it's already a bit smarter. So that's the idea. And of course, people now are playing around with that. Maybe also you have come across this DALL-E 2. I don't have any example for DALL-E 2, because if I cannot use it, I will not show it, and there's a wait list and stuff. So basically you can enter a prompt. So you can say, I want to have a room full of programmers, and they are drawing something on the wall, and the system will create basically a depiction of it. The discussion, the currently ongoing discussion, and Emily Bender is currently trying to debunk it. She's from natural language processing, so she knows what she's doing. So people are coming out and say these systems are somehow conscious. So they know they have a conscience. Maybe they have some sort of intelligence. I mean, we could tell the same from the Walser, although we must agree, not the smartest Walser I have seen around. But still, so this is there is some hype going on, because people claim to be that there is some bigger truth in this. But the real problem here, from my point of view, and I think this discussion about constants is really sown with purpose. So also for these companies to have this, so the legitimation to work on this text generator. But the problem that we're really having is, even if the whole system is being open sourced, so there are papers about Palm, about GPT-3, GPT-2, so basically we know how these things are structured. We basically could build it, but of course we cannot, because the data they used to train it is not available. They just crawled everything from the net. That's one of the huge problems with GPT-3, for example. So If you want to have a sexist or a racist or I don't know, other representation of something with GPT-3, it's not a problem. You just start a prompt and the thing crawled the whole Reddit. So you have in there everything evil that you will find on Earth. And so the system can recreate this problematic content in the matters of seconds. So we don't have, so this is basically the opposite of FAIR. We have no data available whatsoever. They just said we crawled the internet. Well, good. And we don't have the computing resource. At the University of Bern, they're doing climate research quite intensively, and the current climate models are usually calculated on Ubelix, on our HPC, on the cluster. But the cluster is far away from replicating what has been done for Palm. So even if they would give me the cluster for a whole month, I wouldn't be able to replicate Palm. So basically, we're dealing with models that are for universities. You can go to Harvard or Stanford or so. It's the same thing, even the MIT. You cannot basically replicate it. So we are stuck with just a model, and we can't really deal with it. So you have to be Google, basically, or OpenAI. Yesterday, I thought about if it's 4 or 5 companies that are able to do the calculation. So it's less than 10 companies on the world, no university that even can do it. Then we have the CO2 footprint that should somehow taken into account, I think. But still, and this is the problem for me, this is why I really want to discuss this with you. Still, these models are somewhat useful because I can do tasks that I were not able to do before. But I don't have really good feeling about it, to be honest. This is why I think the whole care, the care principles come handy. If you say, yeah, we should be doing FAIR, okay, FAIR is basically, you're the producer, you're doing that. But if you start thinking about care, you need to go one step back. You need to think, okay, what does this mean? What's the collective benefit of the stuff I'm doing? What does it mean if I start doing facial recognition tasks? So who is going to be benefiting from that? And especially who is going to be in a problematic situation due to that? Second one is authority to control. So we need to think, what can we do if someone wants to opt out and say, no, I don't want my data to be part of this training anymore? How is it possible that we have systems that really then could scrape this part of the data, or maybe even like destroy the model and redo the model without this data? Whole responsibility. So who is responsible for it and how can we do it responsible? And the fourth, of course, the whole topic of ethics. And I won't go into detail. There are much smarter people thinking about that than me. Interestingly, and I want to point that also out, there's the Global Indigenous Data Alliance that was coming up with this care principles. So it was not basically, of course, it was not a big company, but it was also not a scholarly discussion like FAIR. With FAIR, we always see, okay, if you make people do stuff fair, you will profit. If you're doing it care, it gives you just an enormous amount of work with not directly profit whatsoever. Oh, no, I mean, of course, the profit is there, but it's not so like that. So you basically cannot from FAIR, basically you can harvest. From care, it's a bit different. So it's really about thinking how we should do that. But still, I think care of 2018 is really, I think that was a game changer. Now, to wrap this up, some second part of the interim conclusions, we need to start discussing public infrastructures. And on the one hand, that's key, and the second, and that's the problem, it's costly. So at the moment, we are trapped with infrastructures that are being run by large organizations, large companies with very clear and indicative interests that are not aligned with public interests, I would say. We have FAIR, but FAIR is not enough. So this is why I think care also needs to be enforced. And I'm looking forward that the SNSF is going to pick that up. I'm skeptical that they will do it, but we will push for it. And we need this sort of cooperation that connects scientists, not only as producers and scholars, not as consumers, but rather not flip the roles entirely, but rather think about new forms of cooperation. This is one of the consequences. So we need new forms of cooperations, and we need critical inquiry. So we need to critically engage with the tools, with these models, but in a way that's not harmful. So we need open data on public infrastructures, and this is one very first and very small step. We need some reports on models. So if you create a model, something like we did for the Svizzero text generator, or for example, the text recognition model, you need to do something like model cards. So you need to think about what is the embedded bias within. Each model is biased. There's no way around that, but at least make us aware of the bias. So for the HDR models, for example, it's definitely a Swiss bias. So the text recognition, we had so much Swiss text that Swiss place names get recognized way better than Germans, for example, and even more than English. I mean, that's just one very simple point, but still, we need to have something like model cards. It has been, Mitchell already in 2019, I think, demanded that, but I think that should be basically standard right now. Now, for me, it's really about the questions for today. So, and the remaining questions are: how do we remain independent while we're using available infrastructures? What about the high quality infrastructures that allows data to, I call this to breathe. So we need to switch, we need to be able to alter our data, as I said, because someone or some entity opted out, but also because we have new insights. So we need to be able to have the infrastructure that's also allowing us to change this data. And then, of course, how can we remain or become fair and also care? And then, like the second part, and is basically the open questions, what to do with these irreproducible models? How should we deal with them? Should we neglect them? After all, people are not going to do that, but of course we can say, okay, we will not use it for us, for example. And what can we do with the CO2 footprint of these machine learning models? Thank you.